Hello everyone, welcome to the first test recording of a new series of Code with a Friend. In this particular series, I will create very scrappy videos about how typically I learn. The intention is to capture my methods of learning. I'm not saying that my method of learning is best, but another intention is obviously to improve my own method of learning as well, because the primary consumer of this content uh, will be me. And if anyone else gets benefited out of that, that will be purely bonus. If anyone is watching this video, uh, please feel free to leave a comment of how I can improve, and also what are the suggestions that you have. How do you learn? The intention is also to create sort of a community of learners, uh, primarily around computer science. So, as you can see today, I have a screen of LeetCode open. I'm not sure if the screen is big enough, or the font is big enough. I think so. At least my OBS is showing that. But anyway, so the problem that I was looking at, it's a very simple problem, the two-sum problem. The solution that I have here works like this. It's an accepted submission, so I can see like what are the best solution that uh, is there at least to the Java cases. But I guess like my intention is not to go too deep into the solution, but rather using this problem as a use case to learn different techniques about languages or learn the differences between languages, like how we solve the same problem using different languages differently. And why do we do that? Um, I hope like if you are with a computer science or programming background, we would know what a programming language is and what are the different programming languages, at least the common ones. There are many programming languages. At least what are the common ones? If not, I would encourage to look up what it is. Um, so my assumption is like you would have that knowledge, and I won't interrupt my flow to make things simple for you as much as possible. But if you don't find something which is very much intuitive, feel free to pause and then look up uh, the content that I mentioned there. So the solution that I have tried here, I think it's not a new solution. It's a very old solution that I had tried. Um, so let's go over the problem. So the problem is basically you have an array of numbers, and then you have a target value. I should say array of integers just to be very specific about that. What we want to output is if we have two such numbers in that array whose sum is equal to the target, we just want to output their indices. As you can see, if in this particular case 9 and 2 and 7 should match, so we are saying index 0 and index 1 as answer. If we have an array like 3 to 4 and a target of 6, we would say 1 and 2 and so on and so forth. My, I think like what I mentioned in my talk here, let me just make it dark. It's actually two. Yeah. And also let me fit my screen. So I mentioned this as my vlogging diary. So what I want to solve is like I want to solve this problem in C, and I want to see how I can solve this problem. Similarly, the way I had solved in Java. I think my primary expertise is in Java, but I am not too familiar with C. So I wanted to learn more about C and how you can solve similar problems in C. I'm sure like many people would have that expertise. So the best way to find out like what's the solution is Google. Like I tried to look up the solution in Google, and what I found is like in many cases, folks are solving the problem using an order n square approach. So I thought, why not do that myself as well? Let's actually do that. So yeah, let's get to coding. So while coding, what I'll do is I'll try to explain my setup and how I'm solving the problem. and I'll try to be uh, verbose as much as possible. But yeah, that's I think my thought process there. So let me go back to my directory in C. Let me go back to my LeetCode directory under C, and let's remove all because I don't need them. Okay, so this directory is clear now. I can create a new solution. So let me do that. Similar to the name that the other that I created, I'll create a name like that. I would copy a solution, at least initially, but I would try to create my own. And then I will see if I'm missing something there. And probably I can look up the solution if needed. But I'll create the same name. Um, so it'll start with a number because I want to find that file later, and then like sort of an abbreviation of what the problem is. Instead of a dot, I would use an underscore probably. And let me see if I can increase the font of this terminal. Appearance. Color scheme. Okay, not in color scheme. Yeah, this is nice. Try vintage. Okay, but yeah, I changed the color scheme. How can I increase font? Why is it so hard to just find that font? Word delimiter, appearance. Appearance should have that, right? Languages, always on top, display, tab with mode, rendering, actions. Increase terminal font size. Windows. Terminal app. Okay. Click on that. Oh, interesting. And what? Oh, settings. Okay. Okay, I think I needed to go to the profile. Settings. Actually, I'm on Ubuntu. Ubuntu appearance. Ah, finally. Ubuntu appearance. Let's see what are the fonts I have here. Theme console should be good. Increase the font to 16. Same I would do for this Ubuntu as well. I don't know which one I'm running. And that dump. So let's actually keep it Cascadia code so I know which Ubuntu is what. So let me save this guy, close it, and start Ubuntu again. I think it's a little better. Ooh. Did it actually increase though? Command palette. Interesting. Increase font size. Oh, finally. What's the shortcut to command palette? Control Shift P. So it's essentially similar to VS Code. Increase. Okay. So Control plus plus should it's almost something to learn. Now let's go to LeetCode and I'll go to this directory C. There's nothing here. So I will create a new file using NeoVim, which I'm also trying to learn how to use. And I will name the problem one to some. So let's start. So how do I want to approach the problem there? So what I want to do is like I want to create the similar function signature, and then from main. In LeetCode, I think they have already given the function signature in C. So they have already given this function signature, so I should be copying them and filling that out. And I should also have like a main function where I'll have this test array. I'm not good in C there, but let's say I think the array would be something like this. I can put some random values here, doesn't matter, 2, 7, 8, 10 probably. And then my target, which is 9. I would pass this array to the function and the num size, the target, and I would expect a return size. But return size should be, I think what they mention is return indices of the two numbers so that they add up. You may assume each input exactly one solution. I don't know what's the reason to have this return size if you have exactly one solution. But yeah, you may not use the same element twice. You can return the answer in any order. So eventually I want to return like a two-element array, which will be the two indices, and the return size will always be true. That will always be 2. So just for simplicity, what I would do is um, I would remove this and will create another function. So this will be my toSum internal, and then another function will be exactly same, which would return toSum internal, and it would just put the value 2 here, and then it will return toSum internal nums, num size, type. So that's your basic over-engineering 101. So I just don't want this return size to be in my function. So I made another function encapsulating my function. So my function will just have the nums, num size, and then the target to be matched with, and it will return a two-element array, always. So let's visualize my two-element array. Let's say I'll call this indices 2. Let's initialize both of them with 0. I thought this does both initializations, right? I'm so bad in C. I don't know stuff. I have to like, just try out. That's the good part about programming, though. Like, there is, I mean, just try it out and see what's the answer. That's the amazing thing. That's how you learn. So today, maybe, I don't know, tomorrow, I'll know for sure. Anyway, so what do we want to do here? We want to do like an order n square approach. So let's see if I have just summarize my approach here. So if I have an array like this, 2, 7, 8, 10. So I'll first iterate. What I'll do is like for each of the element, I'll check with each other element in the array. So I'm back after the break. What I was trying to do here is basically iterate over this array twice, and then I'll just do a brute force search basically whenever two indices are matching. I would just return them like these are the two indices. So let's create two for loops and iterate over the for loops. We'll need two iterative variables. Start from that to num size side. Well, there is no point comparing I with j, and these are like indexes. So I'll start from j as 1. The first thing is like I should not be equal to j. I think that's a basic check that we can do. And I think we can also club it here. Nums I plus nums j is equals to target. Then what we can do here is we can put this as 0 as I, and this is 1 as j, and return. Return, we have to return the array itself. Or what we can do is like either we have to return something. So we can return indices from here just for the completeness of this program, but based on the data set, what is mentioned here, like we will not have that scenario where we come to line number 24. This won't happen. Actually, yeah, so we will come obviously to line number 24, but we will find some value in this for loop. So at least for this particular scenario. So let's see. Now I think our return size. So I would test this function. I test the toSum internal function. So let me see. It's an integer pointer. Let's call it indices to some internal. I send array. I send for. Send target. What would I do here is I just iterate for mine instead of mine getting. I have another index here. Oh, I don't need to even iterate, right? I can just print both of them. Printf %d, %d indices 0, indices 1. Right. So does this program compile? No, there is a bunch of warnings. Returning int from a function with return type int star mix pointer cost. So it turns out code is wrong somewhere. It is saying do some conflicting types for some internal, and then what I'm doing. Yeah, actually let's simplify. I think I'm making some good work in this logic here. So let's just enough and when for today. I'll come back to it later. Let's just do it on code for now. So I'll comment out this for now and just use it. Oh, okay. Oops. Return indices. Function returns address of local variable. So what we have to do here, we have to initialize the variable. I think the part that I'm not too sure about in C is channel also. Then the thing won't be required to be that big. It should be fine. So we have to define the variable here, but so we have to do a malloc of this. Let's actually do that. Then I think we will do a proper allocation. Int result. Okay. Int pointers. This is now. Int star malloc center int multiplied by 2. So for malloc into the header inclusion, it's compiling 0 and 1. I think I should give probably a backslash in here. Okay, nice. So this is working, and now I guess like the problem that I'm seeing here is the time that it's taking. So for that, what we would do is basically create a large array. So now I think the next question comes. First thing that we do is implement it. Brute force solution, which is order of n squared. Now I think we know that this is bad, but it would be also good to see why this is bad. I think that will be an interesting lesson. So what I'm particularly interested in is what would be the time difference if we actually change this as solution. So let's go back here. One way to do this is implement the same solution in Java, because in Java we already have the map implementation. So if I go to my Java directory. I think I don't have the map implementation here. LC1, right? LC1 should be here. Okay, yeah, so we have the map implementation here. And let's actually create another implementation, which is a little bit inferior. So what I'll do is basically copy paste a bunch of things from here. The signature will remain same. We won't use a map. We will exactly use the C style definition. So let's just keep this as a reference on this side. And we just need to return a new integer. So let's create another inner loop. And then what we would do is we would do similar kind of check. If I is not equal to j and nums I plus nums j is equals to target, then we will return integer array index. All this not required, right? So I think we can just return these two, and then just, I think this is just for completeness that we won't expect anything wrong to come here, so we'll expect this to. So what is it saying? Okay. Now let's see if I can compile this one. Yeah, I can. Please define the main method. Okay. I guess I used to use like a single class for main, right? Okay, there is no main function here. Well, I can define a main function. Or should I do like a runner implementation? At least in Java, I can do a runner class. Let's see. What do I have here? I don't have any runner implementation. So let's create like a runner class. What this runner class will do, it will have like a main function. Yep. Then VS Code has this shortcut. It automatically populate and create this boilerplate the Java needs. What I need is I need to include LC11. So I'll have this class. Or it's a static function, right? No, it's not. So, and then we need to have this array to sums. This says C1 to sums send this array and start just like, and I can just print out. I think I can do println. There was a shortcut to do fast print statement, but anyway. So I can just do this as 0 plus this is 1. Okay. So now what we can do is basically we need to create a benchmark for performance. So basically the way we measure performance in real life setting is creating some kind of benchmark. So this runner function can be used to create benchmark for this particular problem. So typical benchmarking we can do is we can create a random stream of elements. The only validation that we have to do is like we need to pick to ensure like this actually exists. We need to pick two random indices and then create a target out of that. So that would ensure like the assumption that we are making here, like we would always find such indices that's it satisfied. Once we do that, then we can just give it to this function and let this function calculate, and we can compare how much LC1 and LC1 underscore 1 is taking based on that. So let's create our benchmark setup here. For that, what we need to have a public static I think I can't return array if I remember. Oh, in Java. Can you return array in Java? Let's see if we can. But you need to have this. Okay, so yeah, okay. Java utils star. And then I can create an integer return. Create this data. And what I can specify is what's the length that I'm looking for. What it would do is it would also need a random function. So for this data set, it will create a, so I'll also need a random, I'll use this random class. I think so, probably in Java of a specific range. So this random, okay, Oracle. You can return string and stuff, but I guess like we are fine to have a next int. So if I have a random object, I can create like, I know like what's the length that I'm creating. So I can have this data set of the size and then this test data I will index will have a next end, and that could be a bound. I would say 1000 for now, or we can also customize the bound here. Once we create that, then we'll have our own test data, and we can pick two indexes using the same random next end, which should be within length the same random dot next end length. Once we have that, then we can create our target as well. So this could be the last element, could be my target. So I can create like a, I mean, these are all hack, right? So we can all create whatever we need. At this place, we can create test data like this test data chain, and then we can just return test data. So what this would create is like create test array, create the target. So now we see that this is the value, and so we have created the test array, we have created the test target, and now we create the test data. Let's see how we can generate a similar array for this. So for that, what we need to do is can create the test data here. Create test data of length 4 and bound is 10. So it will return me an array length of 5. What we need to do is we did need to do another array copy here. So let's say copy array in Java. I need to create a duplicate array. I think the arrays class would have a helper method to do that. So I think the Oracle doc might have some help here. Copy of integer array copies the specified array, truncating or padding with zeros if necessary, so that the copy has the specified length for all indices that are valid in both the original array and the copy. The two arrays will contain identical values. For any indices that are valid in the copy but not the original, the copy will contain 0. Such indices will exist. So original is that, a copy, truncated or padded. So what I need is truncated. Let's see if it does truncation. It's within Java util arrays, so I should have that. So my array will be arrays dot copy of test data dot length -1. So this would be the array that I will be passing around here, and my target would be test data length length minus 1. So what I need to do, I need to also print this element here. This array has a print function. What other helper function do we have here? Let's go up. So I believe this is print. Oops. Binary search copy of equals type equals fill hash code parallel prefix parallel sort split iterator string toString. I think toString should be good. Returns a string representation, a comma, something like that. That is what I will need here. Let's go back. So what I need to do here is I just need to specify that what my output is, at least for the testing purposes. Like when I'm small data, I can understand at least my test setup is working fine. So arrays dot toString array, and this would be my test array. And similarly, test target will be, let's actually extract the target here just so that it's easy to understand that the last element is the target. We can reuse that. And then it should return us the value. Let's see if this is compiling and it's running. So what it does is it creates some, so see how beautiful it is. Now we have created a program to create an input for the toSum problem. So we have the test array, we have the test target. Now we can create this. Let's run it another time. So now the input has changed. It's 5398. The test target is different, but we are able to create that. Let's actually change this a little bit. Let's make it, let's say, 10 element. And what we'll do, we'll compile again, we'll run again. So we have these values and we say 18. Where is 18? I think it should be 9 and 9, which is what it's finding here. We do this and it's say 2. It could be like 2 and 0, I think. And then we can do similarly this and 10, where we can find 10 here. So it's like an interesting thing. So now we can create like a arbitrarily large number of array with arbitrarily large number of bounds. Compile and we run it, and we have like a, so this is like really hard to comprehend, and we have to trust like our program is probably working fine through that. The interesting part what we want to measure here is benchmarking this function. So how do we benchmark this function? Typically benchmarking works if you test your function with different set of input values, and we want to see how that function, the cost of running that function is growing with that input size. That's how our entire story of big O notation comes from, right? So that's the, I think, the last thing that we want to do for this, and probably in the next video we would try to see how we can do similar things for a C program, and we can also see how it actually what time does it take to run a C program or a C++ program? And that's something I'm curious to know. So that's why I'm trying out, and I'm just creating a video out of it. So let me know if your thoughts on that, how you can also do benchmarking. But this is, I think, my thought process of creating a benchmark. So let's do that. So what we will do is we have at least the capability now to create different values of inputs. So we need another value to properly have the access is what time does it take. So that is, I think, quite straightforward to do. So we'll have a start time. So before calling that, we will just call the system function to get the current time. And after executing that function, we will find what's the time it took to run. Assuming, I think, this is correct. So what we would print here is time taken. Let's actually see if we can do, I think we can do a system out printf also, right? Printf is also there here. So I need a formatted value. So what I'll do is like time to run %t or time to run array of size %, let's call it 60, is %. So it's a long, I'll translate. So long will give me in millis, but I'll translate in seconds. So it'll be like a float, and the float that I want, I think till 6 digits after the decimal point, and it's seconds. So in here, what I would have is the first %d is the array length, and the second %f would be star. I can actually calculate that also, just not to. So it will be a double, and double would be minus start divided by 1000, or we can do the other way around as well. We can just do a 1.0 divided by 1000.0. Ah, shit. Multiply by n minus start, and then we can just copy this duration here. This indices is not used anywhere. We can probably print it, but we don't need to print that for now. Let's just park it. So let's see. Let's see in the current scheme of things if it's running or not. Probably we need \n here. So as you can see, it's like per 1000 element, it's nothing. We don't need these values for now, so let's hide them out. So we have this. So it's actually nothing still. If we want to print that in millis, I think it's LD second, too sure, where we can just say n minus start. I'm not sure if long would have LD though, but yes, I think the formatter is a problem. I think it's %LD, something like that. Okay, now I think I need to find the formatter. Printf formatter for long is it still int though? %d though? Printf specifies unsigned long. %lu. Let's do that. So no, not able to find. Just do here. Let's see. So it's actually saying 0 millis. What about if I increase to this many size? It's still 0 millis. Still, are we getting anything here at all? It's actually interesting. Is it doing anything at all? Let's just print end and start separately. %DUNS. So these are exactly the same millis. Just to check if it's working fine, what I can do is probably do like a sleep here. But this sleep won't come into picture. I can sleep in here. Maybe I'll sleep for just 1 millisecond. Let's just throw. I need to do a rapid try catch. Very hacky try catch. So let's wrap everything together in here. Just catch that interrupted exception. Nothing on that. If this thing happens, it's not perfectly fine. Okay, so now things are changing. So if we are sleeping there, things are actually changing. Let's sleep for more once we find that. So it's actually taking a little bit longer. Let's actually sleep for a little bit more, up to 1 second. Just wait. So now we are actually sleeping for 1 second, and that is the time that's getting added here. So the comparison is like so fast, and it's not even checking there. So what I can do is actually try to see if there is a way, even if we can go into narrower granularity, like nanoseconds. What about that? Get current nanoseconds Java system nanotime. Okay, should be what? So system nanotime is a long. Okay, cool. And this is also a long, and then this is the duration. So this will essentially be my milliseconds now, and these will be my nanoseconds. But essentially I'm still interested in the differences, so I would just wrap it together to let's rerun it. Now let's try to reduce this to 1 millisecond. So which will be 1000 nanoseconds now. So it's sleeping. Interesting. Even without sleep. Or let's say I do sleep, but not sleep. Now interesting. So what we can do is just run this entire thing in a loop. For integer I is 1 and I is less than, let's say, 1,000,000,000,000 I plus plus, and wrap this entire thing under this loop. It's not a plus plus, it's actually multiplied by 10, so every time we increase that, we don't have any I here, so our I will be that, and our bound should be same. We can create like an arbitrary large array, but our bound could be same. Or we can also increase the bound along with it. Let's say we always have a bound of multiplied by 10. Do we have any overflow here? What's the upper limit for int max limit in Java? So it's 2147483647. So there are like three. So it should be around like 2 billion, a little bit over 2 billion. So we can go till 1. We are not even going. We can go till 1 billion, and then the bound would be 2 times out of that. So then we should be good. Let's see if we are able to run now. Illegal argument. Let's be a little bit conservative. So now we are hitting illegal argument exceptions because we are creating arbitrary bounds. Let's see. This is interesting. Why are we hitting it here? So the test data, okay, so if we have just one test data, like this doesn't make sense. So could be that. Now let's try to understand this. So we have a test data, then we have a bound, then we create an array out of it, we create the target out of it. And how does this actually include? So we are encountering illegal argument exception, which means that it's not able to find that. But it should be able to find that, right? Like we are not modifying any logic here, just to cross-check if we have made any mistake while adding that loop. If we have 100 range value, so 100 range is taking now this. We don't need any thread sleep here, so let's pull this one out, remove the try catch.
So now for 100 we are taking 19.3 millisecond. And if we increase this to 1000, it's actually 203 milliseconds. Nanosecond is now sort of useless, so I'll skip this. And increase further. It's increasing. But it is interesting actually. Like nanoseconds, nanoseconds to milliseconds. Yeah, I think the conversion is not right. That's why it's nanoseconds to, yeah. Unfortunately, wrong calculation. My bad. Yeah, now it makes sense. So it's 1.86 milliseconds. So this is, I think, a good learning. So that's why I think all our benchmarks should run in nanoseconds, and then we can actually see the some number there. Otherwise, in milliseconds time, this is like 1.86 milliseconds. And if we do like a current milliseconds timing, it'll probably be lost in the blue. So increase that to one more. Interesting. So this also has a dependency because we are adding two set of randomness. One is like we are creating the test data at random, and then we are also picking the target at random. So the target should not also be a random one. This is, I think, a very interesting point. I think for benchmarking, we should always evaluate the worst case scenario. Then we can have a consistent comparison across all runs. One issue we have here, we are creating the target inside this loop. We can probably avoid that. So what we can do is we can just return the test data, what we need here. And we don't even need to copy that, anything. Our target will actually be the sum of the last two elements of the test data. So we always know that that's our worst case according to this algorithm, and then the comparison numbers will be in that range. So if we have test data dot length -1 and test data dot length -2, so this becomes my target, and this is my array, and there is no element named array now. Array is not there, so it's all just test data. Okay, now we write multiple times and is it always finding the same answer? That's, I think, now becomes even more interesting. It should also find the same answers, right? Then I think we can be very sure that the comparison, because what can happen is, since we are creating two random numbers, we can run into an issue of coincidentally For example, in this particular case, why is it taking so less to run? I think it is because if it's a function of the input is also changing there. So if we keep a track of the results that's coming out of it, and we also print that, consistently we should get the same answer. Or if something is changing, which means like our random input is not correct there. So what we want to do here is we just want to do indices 0, comma, indices 1. To compile it. So 0, very interesting. So now I think our intention should be, it should ideally be 100,000. So 99,999, 99,998, those two indices should come in the answer, but it's not coming there. If I run again, it's again not coming. If I run again, it's again not coming. So what we can do here is also to remove this random principle. We can just make it quite simple. Just do this one. Not use the randomness for now. So it'll be basically like every element will be unique. And then the last two elements, that's the target sum. So we're even removing the randomness, which we included. See, now I think even I think here it's not correct actually, because so what's my target that I'm giving here? Let's see. Target is this. So if I compile it, interesting. So my target is this, but it should not be the target. My test data length should actually be more than that. It should not be test data length. If I mention this explicitly though, something changed then. Okay, something changed. Amazing. Amazing. Now it's actually, yeah. So finally we have hit the worst case scenario. So test data length ideally should be that. I don't know why it's not coming as same as that. But let's also try to see if okay, so now I think the last bug is to be fixed here. Why am I not getting 100,000 in test data length? What was the previous value that was given here? And that's actually changing, right? Which means you're not getting test data length here. That's interesting. How can this one be? Should debug once. Oh, I think I don't have the debug set up here. Okay, anyway, we try once more. Anyway, I will do a print debug. What's from system dot println test data dot length -1 test data length -2. Which one is actually, so first one is becoming 0. Why? What is the value of test data length -1? Oh, is there something? So subtle bugs. I think now it should go fine. Yeah, it's taking time, which means it's working fine. 7 seconds. Now I think even we can do like, yeah. Anyway, so coming back to our original intention to put this guys in here and in here. Let's put this high. Bound wouldn't matter anyway, so doesn't matter because bound I think we are not using anymore. So let's just keep it for now. So yep. So now we are getting some values out. Let's keep this so we can see what's the. Now let's increase. Starting from 10. Now we are seeing proper benchmarking. Let's stop this. Can't interrupt. Okay. Should I stop it from the task match? Okay. Terminal process failed to launch. I think I hung my PC. This is weird. Why I can't interrupt. Terminals are still running. Okay, this is the one terminal running which I don't need for now. Okay, stop to close. So Firefox, yeah, I think these are the two things running now. Let's run my Ubuntu once again. while it's trying to run, okay, it has come actually on my other monitor. So tools, LeetCode, C, and no, not it's C. Java for now. Open it in code. Oh, VS Code. What happened to VS Code? Crashed over. Runner. Let's see. So we'll not go into that level. I think 100, a million number is fine. Otherwise, I'm crashing my PC. Cool. So let's do a recompilation here. Now let's run 10,000. Fine. Okay. What if equals 10,000 is 91 milliseconds. 100,000 is 5 seconds. Now a million. So now this is quite interesting. So if I see how it's sort of leapfrogging from 0.005 to 160, that's a jump of about 30x, and 0.16 to 3.3, that's about 20x, then 0.3 to 91, that's about 30x again, then 91 to 53, that's like a 60x jump, and a million is still running. So it shows how the code can become worse with increasing numbers. I think it might crash again. Will it listen to my interrupt? Do I have to stop it through Task Manager again? I don't know which code it's actually running, but I think it must be one of these terminal values. So the last part that what I'll try to do is, okay, we know like this takes the worst case scenario, we have actually hit order n square scenario, and that is like making the PC so slow. Now, if we just simply swap the classes, instead of using that order n square, we use order n, we can see the benefit. We should be able to see the benefit. So let's let this guy run. I don't think, I think we can still create another version of it. So what we will do here, we'll create a version of LC1. So if we remember, LC1 actually does use a map. So it should not degrade that much with increasing input. So let's see, and we'll test our hypothesis there. So what we will do, we will swap in this with that, and we'll create a new terminal, run the code there. And now let's see. And this basically shows the entire purpose of this video. So we all know what order n square means, or how the Pico notation actually impacts program performance. But here you can see that in practice, with increasing input value, this program does it in order n time, which sort of increases linearly with the input number. So we probably all know it theoretically, but the good thing is like you can actually also test it in practice. And this is just a demonstration of that. Thanks everyone. This is a very long video, but it's a good learning for me as well. See you in the next video.